I originally wanted this to be a very informal session without slides and just me chatting with you. Obviously, that's not possible in the online setting. So I do have some slides. But I hope we can have, these are just a support for the discussion that we'll have afterwards. And apologies for my rusty voice. Let's hope it keeps to the very end. So actually I put this title, but that's not entirely what I want to talk about. So 10 years ago, when I was a newish editor, and at that time I was an editor at Nature Physics, I was giving these publishing talks, and I always talked about two main things: how to choose the journal where to publish and how to write the abstract and cover letter. And as I was updating my slides for this presentation, I realized how obsolete these topics are today, for two reasons. So first, compared to 10 years ago, there are many, many more journals, and the choice of what journal to choose is very different from what it was a decade ago. And second, now we have access to ChatGPT, so just let it write your abstract. Why do you need to bother? That said, I'm still going to talk a bit about how to choose a journal, and I'm still going to talk a bit about how to write an abstract, but from a different angle. And I'll also tell you how reviews are made, in particular Nature Reviews Physics, because the majority of our readers are early career researchers, so it means people like you, presumably. So it's nice to know how the reviews you're hopefully reading are made. So let's dive in, and I'll start. Just a moment. I'll start with this not very good slide about the Nature family of journals. So there are lots of journals out there, and traditionally I would have started saying, oh, you need to know who's reading these journals. But today, nobody's really reading journals. I think most of you are finding information either through Google Scholars, alerts, or just browsing the archive. So very few people still read issues, and very few people read entire issues. And there are lots and lots and lots of journals by different publishers, overlay journals, different types of models, and so on. But even within the Nature portfolio, there are lots of journals, and sometimes even we have trouble knowing what is what. So just wanted to give you an overview. And to point out some important things that you need to be aware of so you can differentiate between different titles. So we have weekly journals, and that is, well, the mother journal, so to say, Nature, that publishes most significant advances in science, and is published every week and has roughly 1,000 articles per year. These are not just physics, these are all sciences. I don't know an exact number of how much is physics of these 1,000 articles, but you can imagine it's hundreds, it's not more. Then we have more discipline-specific journals that are published monthly. These are Nature Physics, that you know, maybe Nature Astronomy, and they publish landmark papers of interest to their discipline. They publish roughly 130 articles per year, so a bit roughly same as Nature, just restricted to that discipline. And yeah, both Nature and the Nature more specific titles, they publish continuously, but then they're gathered in issues. And whereas Nature or Nature Physics are still printed, new titles like Nature Astronomy are completely online. And then we have journals that have continuous publication and they don't have issues at all, as Nature Communications, which is again, like Nature, a cross-disciplinary journal and publishes high-quality papers from all areas of science, more than 7,000 articles per year. Again, I don't know exactly how many physics articles are included, but let's assume 1,000 something. And we also have, again, further specialized journals like the Nature Partner journals. That's what MPJ stands for, such as MPJ Quantum Information. Again, it's publishing continuously and has reports advances that are interest for a very specialized area. There's also Communication Physics, which is also an open access journal like Nature Communications and MPJ series, and they publish across all areas of physics. These don't have issues, and then they have continuous publications throughout the year, and they have a few hundred articles per year. And finally, there's monthly reviews journal, such as Nature Reviews Physics or Nature Reviews Materials, publish very little if you look comparing with the amount of primary research that's being published in our sister journals, publish roughly 48 reviews per year, covering all areas of physics. All the reviews titles in the physical sciences are online only. We never had a print issue, and they are they're subscription based. So that's quite a few journals already. But like when you say you'd like to choose one, there are a variety of things that you can think of. For example, who reads it? Although I just said earlier that people mostly read archive or like through find content through search engines, but there's still like some things that you want to think about. So say across the Nature portfolio, we have various options: open access, subscription only, or hybrid. In terms of primary research, now most journals, I think all journals would offer like some open access option. Some are hybrid, so you still can publish without an article processing charge through the subscription model, and other journals like Nature Communications or Communications Physics, they're completely open access. And reviews are still subscription based. Then you can think, okay, who's going to handle my paper? So for some of these journals, there be in-house editors like me, who are trained academics who left active research to pursue an editorial career. Some journals have a mixture of such in-house editors, so professional editors and academic boards, and others have just academic boards. You can also think about the volume of publications, because that kind of gives you an indication of how likely you are to succeed if you submit to one of these journals. Of course, if they publish very little, their standards would be very high, because they'll have to select a very small number of papers out of what's submitted to them. Whereas a huge number of publication volume, say like in scientific reports, over 20,000 per year, then you have a very good chance of getting published as long as the results are correct. And then you can think, okay, what's the scope of this journal? Is it multidisciplinary, or is it discipline specific? Or is it like field specific? So for example, a physics paper could be in an interdisciplinary journal like Nature Communications, could be in a discipline specific journal such as Communication Physics, or can be in a field specific journal such as MPJ Quantum Information. And if this was not complicated enough to make your choice quite difficult, you can also publish in the Springer Physics journals, and there's about 50 of them. So I think it's quite complicated to choose a journal to publish in. There are lots of things you need to take into consideration, and I think even though the choice has increased a lot during the past few years, I think there's still things that we always need to consider. And one of the pieces of advice I always give is like check the journal website and see what are the conditions, because very often people after the article has been published go and say like, can we make it open access? And that's way too late in the process. This is something that it was important for you. You should have checked at the very beginning, even before submitting the article. But luckily there are more options now, but it can be changed after publication. So if OA is important, check it before you submit. Okay, so reviews. Why do we need reviews? I really like, you see this mountain of papers. This is it's a bit old infographic now, but something that I like very much. It's from 2014. And at that time, the Nature News, people made this infographic and they calculated that if you were to print all the articles ever published and stack them on top of each other, you'd almost reach the top of Mount. What mount was that actually? I can't remember. Maybe it was Kilimanjaro. But anyway, it was very, very high stack. And only the very, very top, tiny, tiny top would be the top 100 cited papers and the papers that, are read. Most of papers are never read and just go like somewhere at the bottom of the stack. I think since 2014, we're probably higher than the peak of the mountain already. And it's still growing. And this estimate is quite crude and it only includes published articles in journals. But of course, we have textbooks, we have white papers, we have conference proceedings. There are all sorts of other types of documentation like lab notes or technical manuals and so on that I call dark literature, and that don't even counted in this estimate. So probably like the mountain of knowledge is much, much, much higher. So that gives already a clue like why we think reviews are important, because we want summaries of the progress in a field. We can't keep up with what's being produced. We want pedagogical introductions to help us understand the topic. Sometimes we want a broader context or a bigger picture, especially if you're not an expert in the field and you want, for some reason, to move to another field or to start working on a new topic. You want to see what's going on. And you also need a dictionary of technical jargon, because the way some terms are used in some areas are not necessarily the same that are used in other fields. You'd like to uncover connections or new angles, and you'd like to find information that is otherwise hard to find. So, example, things that are known by people working in the field, but they're not necessarily written down somewhere. So what is the best technique to measure something? How does a method compare to another method? So for all these reasons, reviews are useful, but also they're difficult to write. And I will get back to that. But I want to say, like, reviews are actually a very difficult to define article type because they come in many flavors. I would say they could be anything, in the sense that it could be anything that doesn't have an original analysis, an original hypothesis, an original result. They can be forward-looking, so not necessarily just overviewing what has already been published. And they can be opinionated, like perspectives, and showing their new directions, like roadmaps. Another type of opinionated review is viewpoint, where the different people, authors, who write their own take about a specific topic or answer questions, and then everything is collated together. So it's a collective opinion piece, but the opinions don't have to be in agreement necessarily. They're the tutorial type reviews that are comparison of methods and techniques. We call them technical reviews. In other journals, it's actually called tutorial reviews. They're methodological guidelines. How to measure something, how to benchmark something. We call these in Nature Reviews Physics expert recommendations. And of course, they're like reviews in the traditional sense, the ones you're most used with, that give new angles, bring together different topics, and provide like a critical discussion. So they're not just what we call like a shopping list of what has been published, but they're packaged in such a way that they bring some new insight or some new take on the discussion. And those are like perhaps most useful ways of understanding what's going on in a field. So as you can see, reviews come in many flavors, and I'm always surprised like how every time like we commission something and then we're thinking and discussing with the authors what type of articles should it be, it's actually same topic can be approached in different ways. And sometimes, we could have different reviews with very different flavors on the same topic. So to give you some examples, I don't want to dwell too much on that. So, like a roadmap would be like this one, talking about what people think is going to happen in gravitational wave physics in the next decade. They can be this is forward-looking, it can be backward-looking, like this viewpoint where different people discuss the quantum Hall effect 40 years on. And they could be methodological, like in these expert recommendations, is like how to use like likelihood ratio tests correctly. They can be opinionated, like this one on scientific understanding with AI. They can be very pedagogical, like this randomized measurement toolbox, or they can compare a variety of codes and how they are applied, like in this technical review on cosmological simulations of galaxy formation. And they can be short and discuss in context some exciting new result, like the one at the bottom on the expansion of the universe that was very trendy a couple of years ago. So how do you make such reviews? Of course, it's not straightforward, and that is the reason why we only publish so few. It's a long process, and I've tried to outline in 12 steps. So like every 2 weeks or so, my team meet and discuss commissioning ideas that we have come up with based on conference attendance, on browsing the literature, on searching for different things. We have a variety of methods to identify ideas. Then we discuss them amongst ourselves, and usually the recipe that comes with the editorial law is that the right topic at the right time by the right authors will give you the best review. Of course, it's difficult to get all of them, but the questions that we ask each other when we present a commissioning idea is like, why this topic, why now, and why these authors? So basically answering these questions. And yeah, we challenge each other to bring reasons like why we think this review will work. And once we fleshed out the idea, the editors go and invite authors to discuss the scope, angle, format, possible co-authors, and so on. I have to say at this stage, the idea might get into a completely different direction, because what we think is interesting is not necessarily what the authors have in mind. And then we need to discuss like what we want, what they think is important, and we usually get somewhere in between and agree broadly on how the review would look like. Then the authors would draft an outline that is like a table of contents, and like they would say like, here's what we're about to write, like this is what display items we would like, and so on. We discuss that too, and then the authors start writing the review, which in principle takes a few months, in practice takes much longer. But like some months later, some years later, sometimes the authors send the first draft, and it's discussed with the editor, who might say like, you need to do some changes because there's some things that are missing, and the referees will point that out. Sometimes they're good as they are, and they're sent to peer reviewers who provide extensive feedback. They're usually seen by at least 3 referees, and we try to balance expertise, seniority, let's say theory and experiment, and all sorts of different things. And sometimes you have like the perfect balance of referees, but they don't agree to referee because you're busy. So you have to go back to square one and try to get like the balance right. But that is important, because it, unlike the peer review for original research, peer review for reviews is meant to ensure that the balance of the literature covered is fair, it's appropriate, that what the authors say is correct, it's not misleading in any way, and that ultimately that the review will be useful for the stated readership. So then the authors revise the manuscript and usually undergoes another round of peer review. And then the manuscript is accepted in principle, but we're not done. So at this stage, I will start editing in depth, not only the text, but also like discuss the figures and try to simplify them. Because as you see in this example, figures can get quite complicated. The art editor redraws the figures, then the authors check the edits and the figures, or answer my queries, and we converge on the last version, which is sent for typesetting and production, and the review is finally published. And this journey can take anything from 6 months to a year and a half. So, and it's not always a straightforward way as emphasized by these steps here. And I think what makes it, when you look at the figures, I think that shows you like most clearly like with the before and after. You know, sometimes the figures come in, like you see on the one side and end up as you see on the other side. And that's all thanks to our amazing art editors who are very, very good at working with very sketchy sketches. And they're also very good like bringing up like the information in the best way. To be honest, not all changes are that dramatic and not all figures look that nice. In my case, the articles I handle most have boring graphs, so there's very little you can do with those. Okay, so that's with reviews. And I said, like, this is what I used to talk about. Why do we write cover letters and how we do that? And again, you'll tell me like, nah, I'll ask ChatGPT to write a cover letter. They do a good job. Well, not as good as this guy who, I don't know who this person was, but like became legendary with the editors for the best cover letter ever. But leaving that aside, jokes aside, the writing a cover letter is still useful because, as one of my colleagues wrote in this blog post, is like a very good list of tips on how to write cover letters. This is your 10 minutes alone in a room with the editor, making the case for why she should care about the work. So if you're just going to write down like what's already in the abstract, what's already like the title and things that are already known, it's waste of not paper, like it's waste of virtual paper, and you might as well not write it. So you want to add something different, that is something more that is not already obvious and it's not already clear from the paper itself. So I'll just give you some tips here. Like, it's like a pitch. So if you're a journalist and you want to write a feature, say for a magazine, you have to write a pitch. And most pitches are rejected by the editor and very few go through, and they're like actually workshops and all sorts of things, how to write the best pitch. In this case, the recipe is quite simple. So what's the problem or question? Say, and just a very brief context, because it's not always obvious, you know, like we've solved cancer. Yeah, then it doesn't need a cover letter, but we haven't. So it's just a step towards healing, curing cancer. So you have to provide a bit more information there, like exactly what the problem is and what the question is and how we're going to tackle it. So what's new? What's the key finding related to this context? Why is it important? How it advances our understanding or how it solves anything? And why we care. And actually, that's an important bit. You care because you work in the field, and this is like a big thing you've been working for years, but it doesn't mean that the journal cares about it. Put it simply, not because the research is not important enough, but maybe it's not in the scope of the journal, or maybe it's too specialized for the journal. So they like having a good understanding of what the journal publishes, what's written on the page about the aims and scope, and what they've published previously. It's good to know, because then you can say, why that particular journal will be interested in publishing this particular paper. And to give you an example of how people don't read the instructions and are not aware, like every week we receive submissions of primary research, although it's clearly stated on the webpage that we only publish reviews. And I mean, on the one hand, it's understandable because in physics, we have this language abuse where we like to call reviews, we have reviews in the names of journals that publish primary research. So it is very confusing because there are lots of journals that have reviews in the title and publish primary research or a mix of primary research and reviews. So it is confusing, but that shows that it is important to look briefly at the webpage of the journal. So again, like how to write an abstract, I think there's still like a good approach that I like to advertise how to think about it. So even if ChatGPT writes your abstract, at least you can use this recipe to check if it's done a good job. And from what I've seen, what I played with, it doesn't generally. So you start with what did you do? And this should be clear, like that you measured something, you calculated something, you analyzed something. That's always pretty clear. But now, how do you package this in a story that the readers would be interested in? Because unless the people that work very closely with you, they don't know why this measurement or calculation or analysis is important. So then you say, like, why did you do it? Oh, we don't know the reason for it, or we can't solve a practical problem, or we can't explain something. And then it's like, what did you find out? So we measured or calculated X and we found out something about it. And now what does this mean? And that needs to link back to number 2, because ideally, like what you found out should have somehow answered the question that you started with. So this gives a clue for A, this provides a solution for B, this could help explain C. So we get from the wider context at the beginning to specialist details, and then back to the wider context. And if you want to make this longer, you can say like, how did you do the measurement? Give some methodological details. And also you can say, okay, what does it mean? Or like, what are the limitations? What happens next? So you go from wide to narrow and again to wide. And this is a good recipe because same results can be packaged in a different story depending on the audience, depending on what you want to convey. But starting this way, it makes it easier to identify the story that you want to tell. So what you actually did will not change, but why we did it, what you found out and what it means might change depending on what you want to convey to your readers. And actually, that's an interesting question, whether to check whether you say like you have, whether ChatGPT or you have someone else write the abstract for you, that they will convey what you want to convey. So this is a good recipe like to check. And finally, like we talked about how to pitch primary research, and I just very briefly say how to pitch a review idea, because sometimes we receive also proposals. So remember I mentioned at the beginning, like great, what makes a great review. So it's like you need to answer basically the 3 questions: why this topic, why now, and why you? And if there are existing reviews, like how this complements or updates or adds to them. And actually here, like, it's usually important to make it very clear, like who is this review intended for? Because very often, like you have topics that can be covered in different ways for different types of readership, say, for experimental angle, theoretical angle, like sometimes it's a pedagogical aim or methodological. And like, why do you want to take this view? Why do you want to approach this topic in this particular way? It's also important, and will show like how it is different from other reviews that already exist, or like why would it be particularly useful to the readers? Also, you might say like, oh, if I'm an early career researcher, like I probably won't be invited to write a review. And if I pitch a review, maybe I will not be able to say like, why me? Am I like opinion leader in the community? Maybe people don't want me to write a review, which is not true. Like I wrote the reviews when I was a postdoc. I think they were good, but I obviously am biased. So being early career researcher doesn't mean you can't write a review, but there are also other ways to engage with Nature reviews. So you can review as a senior researcher, which is called our ECR peer review initiative. So when we invite someone to review, we always ask them whether they want to involve one of the younger collaborators as a way to train them on how to do peer review, because whereas you might have refereed primary research, it's not often that you have the opportunity to referee reviews. And it's an interesting experience and it's a good learning experience. So we encourage people to team up with younger collaborators to review together. Or you can write the tools of the trade. And these are like short articles. They're 1 page and they're about a method. And there's the 2 reasons why we introduced this column and why we like it very much is because we think the methods are very important. They're the nuts and bolts of the science we do, but they don't get much the limelight. So they're like usually pushed into the method section, into the supplementary information, and nobody gives them enough love and credit. And the other is like these articles are like single author, and we want to offer early career researchers the opportunity to be single author on a paper, which in some fields is difficult, fields with large collaborations. Even if you're very senior, you don't get this opportunity to be single author. And in others, it's also like when you're more senior, but it's a good experience to be single author and take full responsibility for what you write and also work with the editor on this kind of piece. So these are ways in which we engage with the early career researchers. And before I finish, I just wanted to give some examples like how diverse a reviews journal can be. Because we don't just publish reviews, and we've already seen that reviews come in all flavors. We also publish a lot of other stuff, so say comments that you've probably seen elsewhere, worldviews, which are like very personal calls to action based on personal experience, and they tackle more societal issues within the physics community. We have Down to Business that discusses technology transfer, patents, and related stuff. And we have features that can be on a variety of topics. They're written by in-house editors or like colleagues, like in this case, journalists from Nature. We also publish editorials, and I think our best editorials are the one in April because they're always fun. The 1st of April editorials, watch that for this year. We publish research highlights that can be either on paper just published or what we call in retrospect is like looking back at the paper that was published a number of years ago before, and then in-house written features written by the editors. So I won't tell you about how to write research highlights, but I hope this is useful. And please do ask. We have quite a bit of time left, so please ask me anything.
Okay, so does anyone have any questions? Okay, also there might be some questions online which I'll look out for. Okay, yeah. So actually, when you're asking your questions, there's in the seat there's a mic. So if you just to your right, if you just press that down, press the button down on the
okay
at the front, and then that should.
Cool.
raise a mic. Yeah.
Can you hear me now?
Yes.
Good. So yeah, thanks very much for the talk. So it was very interesting to see your how to write an abstract slide. I sometimes have difficulty to distinguish abstract introduction and conclusion, and many papers write them in exactly the same way. So how would you say, what would you say is the difference?
So I would say that you should write the papers in the same way. So say like journals like Nature Communications, they have standardized sections, which is like results, methods, discussion and conclusions. Well, I know like lots of articles are not written in this way. And it's like really difficult to distinguish different sections. And I would say that what applies to writing the abstract would apply to writing a paper. And you always start like, what you have done, and then how you did it, or the methodology, which in the end, you might put it in the method section, or like it might be kept in the main text. And then after you've done that, and hopefully that's the easy part of the writing, because you know exactly what you did and how you did that, then you can build a story around it. And as I mentioned before, there are different ways of saying, sometimes it's, okay, let's put it like this. Sometimes there's only one way of telling the story. Say like you observed a black hole merger and that's it. But sometimes, and I think particularly in condensed matter or in quantum information, the different ways of telling the story, because it depends on like what you want to focus. So I would say like when you write papers, always write down what you've done and how you did it, and then think like, okay, why, what did we learn? And then like do a bit of back and forth between that and make sure that actually what you say, that what the question that you've stated in the beginning is actually answered by what you've discovered. Because very often people start with very big questions, right? So like, we want to build the quantum computer. And actually the advance is a tiny, 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 tiny step in that direction, but you've set the expectation of the reader very, very high when you stated the problem at the beginning, and then they'll be disappointed when they reach the end and say, oh, actually, this is, or like, I don't see how from here we'll get to building a quantum computer. So, and again, it depends on the type of, on your ambition, in a sense, like how big a problem you want to tackle, but always be careful that you actually answer the question, or like it's very clear like how it relates to the question that was asked stated in the beginning.
Thank you.
But yeah, long story short, yes, apply this to writing papers.
Other questions? Okay.
I just wanted to add that what sometimes happens is the story changes because peer reviewers see a different story. And, sometimes there's a clash between the authors and the peer reviewers, because the authors want to tell a story and the reviewers want to hear a different story. But sometimes, this leads to discussions and leads actually to a better story being told.
Yeah, we have another question at the back there.
Thanks for your introduction and talk. So I have a question about reproducibility. So there's certain papers coming from certain countries where scientists are solving a computationally intensive problem, and they have a budget and they can design their own hardware. They design their own algorithms that couple to this hardware. Everything is very bespoke, and then they produce this wonderful, efficient results. So what's your view on sort of accepting them into nature, knowing that to reproduce this kind of results, you have to get access to hardware which often costs tens of millions of dollars, and it's probably going to be unlikely that any other person will be able to do that.
Yes, so the answer is twofold. So this brings us very much to similar situation where you have like a big particle accelerator and people are reporting the results. Can we trust it? Can we not? Can we build our own and check on the results? No, we can't. Most often than not, we actually can't reproduce the experimental setup or like the data from observation, say like, but what we can do and what publishers are doing, they mandate deposition of data and of code. Now, you're absolutely right. Even if you give me the code, if I don't have a machine to run it on, it's not particularly useful. They're trying to do, to basically encode like instances of running this particular code and do the like encapsulate them and give that for peer review. And also like what people do in more computational titles in Nature, they actually encourage readers to try to reuse the code as much as possible and publish like a follow-up reusability report. And again, like how much you can do that, it depends on the instance. But I think there are efforts to address this, but yeah, very much as in the case of big experiments, we can't redo the experiment or on our own device, and we can't run the program again on our own computer. But in the meanwhile, this is what is currently possible.
Okay, thank you. I think there was another question at the back, and we've also got one online in a moment. So,
Julia, thank you very much for a very interesting talk. I want to ask a question about the game between the writers and reviewers and the journals, in particular the timescales in this process. We know that at least in some countries, the research funding is declining a little bit. And for early career researchers, it means that they spend the early career in a short-term postdoc posts, maybe 1-2 years. But the pressure to produce results with impact grows. And it means more pressure to publish, more pressure to actually publish things which have meaningful impact on a long-term scale. And this is in contradiction. But also we know that in the last 2 years, many journals struggle to encourage reviewers because people were busy doing other things, particularly in lockdown situation. So the review process has slowed down. And it seems that there is now a situation which is even more difficult than it was before the COVID times in this game. And I'm curious how big publishers like Nature, do you acknowledge this? Do they recognize it? Do they somehow want to intensify the work of reviewers? Is there an end to this channel, basically? Thank you very much.
Yes, so actually, this is a bigger problem when you're dealing with primary research because the volumes are much higher. And of course, like people want articles to be published on much shorter time frames. It's still a problem for reviews, but like as I mentioned, like we go like on a much slower time scale. So what publishers are trying to do is actually to tap into a bigger pool of experts. That means both geographically and seniority-wise. So basically go to younger researchers and encourage them to be involved in the peer review process, and also go to more geographic regions. But that comes with challenges because it's difficult to identify people in certain regions because they don't have internet pages in English, because names are not very clear and disaggregating names is difficult, and because there's not a lot of information on the English-speaking web about researchers from different regions, which makes it very challenging for editors to find these referees. And then we go back to like, we're relying always on the same people from the English-speaking world. which is not good, but it's also the people who are visible and who can be found. I read a very interesting article in Nature Careers from last week, where early career researcher talks about the peer review treadmill and trying to get off this treadmill because it's relentless requests for peer review. And now this is a very difficult thing to address. It's like a systemic issue. As you said, there are incentives to publish more and faster, but then someone needs to referee these papers, which, someone has to put work in refereeing these papers. So overall, it's probably not very sustainable in the long run, but it's hard for publishers alone to address it. And because, as I said, it's a systemic issue of how research funding is and career progression in academia is done. And I think if this is to be addressed, it has to be addressed by all stakeholders. And actually your question, I think it links into the question that's asked on the chats, which says, how do you choose a reviewer for a manuscript and how do you ensure they have really read the manuscript? And actually, I have to say I'm worried now because I mentioned ChatGPT a few times, but I don't know now if the report is a genuine report or is like a fabricated report. And this is worrying because we've always relied on trust. Scientific publishing and peer review is based on some mutual trust. So I trust the referees and they trust me to make a fair judgment. But I worry that if people are pushed to unreasonable requests for refereeing, they would try to cut the corners and they would try to get a report quickly that is not the best report. And I would like to say, we always know if it's a useless report, but I don't want to lose the trust in the referees, because I put a lot of weight on their assessments and regarding the question, how do I choose a referee? So this is different from primary research and reviews. So I'll say first about reviews. In reviews, I want a good balance of more senior people who know the field well and more junior people who are likely to be the readers of the review. I like say a balance of theory and experiment, if that's the case, or of different fields, if that's an interdisciplinary topic. And I also want a bit of geographic diversity because people from different regions might have different takes about the progress of a field. When I would, in the past, when I was handling primary research, you need less breadth in that case. So for review, you want broad referees who know the field very well. When you're assessing a primary research paper, you want depth of expertise. So that gives you a very different profile of the referee. And you also want in there some balance, of course, again, theory versus experiment, people who are developing the method and users of the method, for example, or you want to have, again, geographic balance and you want seniority balance, again, because you want a diversity of opinions that will give you more balance, information, and will allow you to make a fair decision. So yeah. Finding referees is tricky and it takes a lot of time.
Okay, thank you. Any further questions? So I think we've already answered.
Maybe I have one.
One more, yeah?
Yeah, so what is your roadmap on essentially making peer review process open? Because you already raised 2 points why that's good, because the discussion that might arise in the review process might be helpful for essentially everyone who would either read the paper or be interested in a field, and second, to actually spot potentially, let's say, artificially produced reviews of which the depth is not, obvious to the non-expert, but might be spotted by someone who's really expert in the field. Yeah.
Yes, so some journals already published peer review reports. Of Nature Communications does that. We don't publish the reports, but we do publish the names of the referees if they agree to. So there's a two-step opt-in system. First, the authors need to agree that the referees will be named, and in most cases they do. And second, the referees need to agree to be named on the papers. This is, I think, general enough for primary and non-primary research. So the referees will be named, and in some cases, the referee reports will be published. What has been seen with publishing of the referee reports is like they're hardly read. So people don't seem to care a lot about digging into. And in a sense, what we see as a published paper is the result of that interaction, is the result of that constructive interaction with the reports, and we see the better paper. So we see the archive version 1 and we'll see the published version 3, 4, that is the better paper and has been made better by peer review. Now, whether people want to see actually the process in detail, what we've seen so far is that there's not a huge interest in reading the reports, but they are available.
Okay.
And not only with Nature Communications, but a number of other journals within the broader Springer Nature are publishing reports, reports regularly.
Okay, any other questions? Oh, yep. Just press the front one. That should come up. It should come up if you let go. Just let go. Yeah, that's it.
Thank you. So maybe a bit of a question outside of your immediate department is about this exactly format that you mentioned of methods and results, and that may be non-typical writing style for certain communities. And sort of the question, are you concerned that this is a barrier for submitting papers, or it's not a barrier for submitting papers in your opinion? Again, there is a community where this is not accustomed to write papers in this way, in contrast maybe to biology, where I think everything is written in that way. So what is your take on this?
I think it's field specific, as you say. Some communities are very structured standard way of writing papers, and some communities don't. And my feeling is that I wouldn't like to enforce a particular style. I like to enforce a style in the abstract, but I would not like to enforce a particular style on the paper, because sometimes it actually works better to get to the results of the very end after you have ingested a lot of background information and you've walked step by step through the proof. So for this reason, like say, when I was in nature physics, we did not enforce a particular style of writing the paper. And even now at reviews, we have a lot of flexibility in how we structure the different reviews. So you see like a variety of, of ways to tell it. Because as I mentioned earlier, the different ways to tell a story. And sometimes the story is straightforward and sometimes it is not. And I'm increasingly of the opinion that it's really hard to tell a good story and in such a way that people will understand. And sometimes you might need like some really unusual style to get to the point. And that's most efficient in getting that point across, then you should use it. But in some fields, it's just always the same story, and then they can use like templated style.
Okay, thank you. We're more or less out of time, but if there's one more question, we could probably fit that in. Okay. Oh, yeah, there is one more, just the back there.
Do you hear me?
Yes.
Perfect. So, at least from my experience, I realized passing the papers through editorial board is hard. It's become harder and harder compared to before. So I want just to know how to appeal how to approach that if we got rejection from the editorial board. Is how it works, or how chance we have this type.
Yes, so I think actually sometimes appeals are a good thing to do. I didn't like appeals when I was handling primary research, but like on occasion, actually, I changed my mind because something new was brought to the table. And I feel like that's the key in an appeal, because editors are humans and we make errors, and we might misunderstand the main result of the paper. And usually a good rejection letter from the editor will explain the reason. So, you know, if it's out of scope, it's out of scope. We won't change the scope of the journal just to accommodate one paper, and that's not worth appealing. But if it's something that, you know, there's a reason why you think the decision should be reconsidered, the key point is to bring something to the table that you feel like the editor has misunderstood or didn't know when they reached the decision. And you have limited information because you don't know what happened in their head, but like, you know what they wrote in the letter. And a way to appeal is basically provide a broader context. And again, think of the pitch that I mentioned about the cover letter. So like, what is the problem? What have we done? What does it mean? And why should your journal care about it? And I think if you haven't done that already in the cover letter, or not in a clear way, that's worth restating. And if, say, the editor says like, okay, it's too specialized, and you want to say, no, actually, the result has broader implications for X and Y. And that wasn't very clear from the paper itself, then you can restate that more clearly. So yeah, just to stress that again, like the key to have success, to be successful when an appeal, is to bring something new to the table. That wasn't absolutely clear in the first version of the paper, in the first cover letter, or that it seems to you that the editor has missed. But like, what doesn't work is like, you're wrong. Yeah, you have to bring arguments, because ultimately editors are scientists themselves. So as long as you can bring new arguments, new data, they will reconsider.